Hello, welcome to Old School Chemistry. We are going to do an equation dealing with colligative properties. It's freezing point depression, and we're trying to figure out how much ice is remaining after we add the solute sucrose to it. So this comes from the Jee Main exam, August 27th, 2021. It was the 9 a.m. to 12 p.m. test. It's question 6. Let's go ahead and read the prompt together. It says solutions of sucrose in a 1 kilogram, that's significant, concentration of 0.75 molar, freezes up to -4 degrees C. Then the amount of ice, they want this in grams, separated out is, and then they give us our constant, our Kf value, the freezing point depression constant for water, and they tell us that they want the answer to the nearest integer. So let's just write down some information to begin with, all right? We've got our colligative property formula, our freezing point depression formula. Change in temperature for freezing point equals I. Remember, that's the Van Hoff factor, is how many particles the solute breaks into. I will post a video if you need some help with that. Times molality. So let's write down some information. The I, the Van Hoff factor, is going to be 1. Is because sucrose is a non-volatile. It's an organic molecule, and so it's not going to dissociate in the water. It's going to stay as 1. So its particle is 1, since it does not dissociate into more particles. The Kf, they gave that freezing point depression constant to us, 1.86 degrees C divided by molal. And then molality, remember, its concentration is mole of solute, that's going to be the sucrose, divided by kilograms of solvent, and the solvent's the water. So let's find the delta T. I want to find delta T for this. Notice my steps. I have 4 steps that I walk through in this thought process. So pure water, we know, freezes at 0 degrees C. Well, this -4, that's the freezing point when you add the solute sucrose into it. And how you get that is you just take the pure freezing point minus the change in temperature for the freezing point. So it was 0 minus the change in temperature. Notice that's just going to give me that the change of temperature was 4 degrees C. The pure water freezes at 0 degrees C. When we added this amount of sucrose to it, the water now freezes 4 degrees lower at -4 degrees C. Remember, freezing point depression, colligative properties, the freezing point always decreases. Okay, so change in temperature, we've got that, which means we can plug everything in at this point. 4 degrees C change in temperature equals 1, that's our Van Hoff, sucrose is 1 particle, times our Kf, 1.86 freezing point depression constant, that's in degrees C divided by molal. And remember, this is moles per kilogram. You can come back here to look at it. Times the molality. Now molality, here's your moles, 0.75 moles divided by X, the kilograms. Now why this is my unknown. So the X, this is going to give us the amount of water that is in that liquid phase. So once you do the math, and I know you can do the algebra, you're going to get X equals 0.34875 kilograms. Well, they want to know how much ice is removed from this. Here's my 4th step in this thought process. We initially began with 1 kilogram. Well, we figured out how many kilograms are going to be in the liquid phase, that we're going to decrease this freezing point, and it will maintain that liquid phase. That is the 0.34875 kilograms, that's the liquid. So if you subtract that, the difference, that's what remains as ice. That's going to be your solid phase. And we get the 0.65, I just convert it from kilogram to gram. 1 kilogram has 1,000 grams, which means in this scenario, we are going to have 651 grams of ice. Nice, well done. So proud of you taking the G exam. Good luck, hope it all goes well. Thanks.